Selecting a motor for an oil pumping application requires careful consideration of several factors to ensure safety and reliable operation. A totally enclosed fan-cooled motor is a good choice for this application, as it provides protection against dust, moisture, and splashing oil. Liquid-tight conduit and fittings are suitable for protecting the electrical cables from potential exposure to oil spills or leaks. They provide a flexible and liquid-tight seal. Ensure that the conduit and fittings are compatible with the type of oil being used. Placing the start-stop station in a National Electrical Manufacturers Association 12 enclosure is appropriate, as it provides protection against dust, dirt, and dripping water. The location should be easily accessible for the operator, preferably near the loading area. Ensure that the motor, conduit, and all electrical equipment are properly grounded to prevent electrical shocks. Consider installing an overcurrent protection device, such as a circuit breaker or fuse, to protect the electrical circuit from overloads and short circuits. Establish a regular maintenance schedule to inspect and clean the motor, conduit, and control station to ensure proper operation and safety. Adequate ventilation should be provided around the motor to prevent overheating. Consider installing oil spill containment measures or absorbent materials around the motor and pump to minimize the risk of oil spills reaching the electrical components. Additional considerations include firstly, grounding, which involves ensuring that the motor, conduit, and all electrical equipment are properly grounded to prevent electrical shocks. Secondly, overcurrent protection should be considered by installing an overcurrent protection device, such as a circuit breaker or fuse, to protect the electrical circuit from overloads and short circuits. Thirdly, establish a regular maintenance schedule to inspect and clean the motor, conduit, and control station to ensure proper operation and safety. Fourthly, adequate ventilation should be provided around the motor to prevent overheating. Fifthly, oil spill protection should be considered by installing oil spill containment measures or absorbent materials around the motor and pump to minimize the risk of oil spills reaching the electrical components. When selecting a motor, consider the horsepower and speed requirements of the pump. The motor must be sized appropriately to handle the load. Check the motor's nameplate for voltage and amperage ratings and ensure they match the power supply. Use a wiring method suitable for wet locations and potential oil exposure. Liquid-tight flexible metal conduit is a common choice. Seal all connections to prevent moisture and oil from entering the electrical system. The National Electrical Code, or NEC, provides guidelines for wiring in hazardous locations. Consult with a qualified electrician to ensure compliance with all applicable codes and regulations. Choose a start-stop station that is rated for the environment. A National Electrical Manufacturers Association 4 enclosure is suitable for wet locations. Locate the start-stop station in a readily accessible location for the operator. Install an overcurrent protection device, such as a circuit breaker or fuse, in the electrical circuit to protect against overloads and short circuits. Regularly inspect the motor, wiring, and control station for signs of wear and tear. Replace any damaged components immediately. Keep the motor and surrounding area clean to prevent the accumulation of dust, dirt, and oil. Ensure that the motor is properly ventilated to prevent overheating. Establish a routine lubrication schedule for the motor bearings. Consider installing a motor starter with overload protection to protect the motor from damage due to overloads. Use a ground fault circuit interrupter, or GFCI, to protect personnel from electrical shock. Post warning signs to alert personnel to potential hazards. Train personnel on the proper operation and maintenance of the equipment. Develop an emergency plan in case of an oil spill or other incidents. Regularly review and update the safety procedures. When installing the motor, ensure it is mounted securely on a stable base. Use vibration isolation pads to reduce noise and vibration. Connect the motor to the pump using a flexible coupling to accommodate misalignment. Use the strain relief to prevent stress on the electrical connections. Route the wiring neatly and securely. Label all wires and connections for easy identification. Use a megometer to test the insulation resistance of the motor windings. Check the motor's bearings for proper lubrication. Monitor the motor's operating temperature to ensure it is within the specified limits. Keep a record of all maintenance and repairs. When troubleshooting motor problems, start by checking the power supply. Verify that the motor is receiving the correct voltage and amperage. Check the motor's overload protection device to see if it has tripped. Inspect the motor's windings for signs of damage. Test the motor's bearings for wear and tear. Consult with a qualified electrician if you are unable to resolve the problem. Remember, safety is paramount when working with electrical equipment. Always disconnect the power before performing any maintenance or repairs. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of the potential hazards of working with oil. Avoid contact with skin and eyes. If oil comes into contact with skin or eyes, wash immediately with soap and water. Dispose of used oil properly. Follow all applicable environmental regulations. By following these guidelines, you can select and install a motor for an oil pumping application that is safe, reliable, and efficient.